Hey, okay, so we gotta go live here. And we go live here. Hello. So, what are we doing? We are going to read the Abacus. What are we doing? We're reading the Abacus. Okay, so here is 0. 0 just means this. That's what 0 means. When we look at it, there we go, there we go. So 0, 0, right? We know how to do that. Okay, so what are we doing? Okay, so after 0 is 1. Now if we look, this is 1 pig. When we have it on the abacus, this is what it looks like. So we have 1. So on the abacus, we have 1, 1, 1, 1, 1, 1. These are all 1s. When we are reading the abacus, we're making sure that our horizontal bar is what's counting our beads. So all of these beads are being counted. This is what we call 1. When we have 1, we will have 2. What? That's too easy. Yes, I understand it's easy because it's simple to use, easy to understand. So when we look, we have 2. This is what, all of these numbers. This is all 2s. So when we're looking at it, we're looking at the 2 beads. That is the value of 2. Each bead that touches the horizontal bar is considered counted. Every bottom bead has a value of 1. Every top bead is a value of 5. But right now we're going to just be counting our abacus. So we have 2. We have 2 snakes. And then, hey, Aura, welcome, my friend. Welcome. We have 3 chipmunks. We have 3 chipmunks. These are all 3s. Those are all 3s. How are you doing, Aura? Do you have any specific questions? Ha ha ha. All right. So what we're going to do is after 3 is 4. What is 4? 4 are these koalas. That's what we're doing. These are the koalas. 4. Hello, Jeremy. Good morning. So this is what 4 looks like. 4. 1, 2, 4. 1, 2, 3, 4. All of these bees that are touching the horizontal bar is considered 4. Anybody have any questions? Okay, that's too much. That's too much. What's going on? Okay, and then we know what 5 looks like. We can go through, and we're just looking at my book that I created for preschool people, preschool children. And so right now we have, it's always good to reveal. Oh, okay, cool, very nice. This is 5. We have 5 horses. 1, 2, 3, 4, 5. So this, with the top bead, is a value of 5. And then we have, oh, you know what I could do is I could do this. So that after 5, we know what 6 is. What? How is 6? How is this equal to 6? 6, 5, all of these beads are 5, and then all we have to do is just add this, all the ones. Hello, Connor, welcome. Welcome back. So here, we're just going to be adding the ones. So 5, 1 is equal to 6. 5 plus 1 is equal to 6. So you'll notice that's 6. 5, 6. And then after 6 is, after 6 is 7. So this is 5, 6, right? These are all 6s. And we have 7 crocodiles. So we go 7, 7, 7, 7, 7, 7, 7. These are all 7s. What's next? We're going to do 8. That's easy. That's 8. So if I show you what 5 is, this is what 5. And then we count 5, 6, 7, 8. I'm sorry, 5, 6, 7, 8. 3, 6, 7, 8, 6, 7, 8. So 3 beads, add the 5 is considered 8. So we have 5, 6, 7, 8, and then together is 8, and then 8. All of these that are, it was nice. It was nice. It was nice. It was a lot of hiking. I did a lot of hiking with all the kids. And so we had every cabin, so it was a science camp for 6th graders. And so I think we had about 70 kids that went. Yeah, it was good. It was good. And then they did a night hike, and then they did at night they did a constellation hike, and then they did a scavenger hunt, and then they did skit night. 6th grade science camp is always fun. But I'm a little sad that will be my last one, because that was my youngest child going to 6th grade. 6th grade science camp. So we have 9 cows. 1, 2, 3, 4, 5, 6, 7, 8, 9. Thank you for asking, Connor. So this is what 9 looks like. 9, 9, 9, 9, 9, 9, 9. That's it. All right. if nobody else is here, let me know if you guys have any questions. Connor, Aura, do you have any specific questions? Ethan, anything? Jeremiah, anything that you guys want to talk about? Or we could just do some, because I know you guys know how to read the abacus, right? Nobody else is here, so we're just going to continue on. Okay, so that is what adding. Yeah, we can add. Are we ready to add? Because there's nobody else talking. So if nobody else is talking, I don't know who else is here. Can you do 10? Oh, hey, Jeremiah. Yes, 10. So to show what 10 looks like on the abacus, thank you, Jeremiah, for commenting, because I didn't know you were here. So when we were looking at it, right, if I did this, we know that this is 0. Because this is 0, this is 9. After 9, this is 10. That's what 10 looks like. Good. So how do I know? Because if I start labeling it, every column is a label. So when we do 10, it's a 0 and a 1, just as how we write it. We write 10. Whoa! That didn't work well. So we have 10. And when I line it up, I'm going to line it up. So if I have my columns 0 and 1, that's 10. So then when I have it, I have 11, 1 and 1. And then I have 12, 1 and 2. That's what 12 is, 1, 2. Does that make sense, Jeremiah? So when we look, we can do our hundreds. Every column is a place value. So I have my ones, my tens, my hundreds, my thousands, my 10,000. And when we have it, we're going to look at the decimal, right? We're going to look at this. That's not a decimal. That is an indicator. That's my ones indicator. That indicator, if you notice, I have 2. And I just need to choose 1 because, just like a Pokemon, I choose you. So I need to choose 1. So I choose this one to be my ones. I could choose this one.
Okay, Charizard, I choose you.
I could choose this one, but then if I line it up, when I line it up, my ones, my tens, notice I don't have any more room for hundreds. I don't have any room for thousands. So it all depends on where you want, how many digits we have, because every column is a digit. Every column is a place value. So when we look, I decide to choose that one.
Pokemon, I choose you.
So now if I look, I have 100. That would be 400. This would be 412. And then this would be 5,412. Give me a number and I can show you what it looks like on the abacus. How about that? Give me a number and I will show you what it looks like on the abacus. Give me a number. 67. So we have our tens and we have our ones. We have our tens and our ones. So 70, 5, 6, 7, and 6, which is the backwards of 6, 7. 6, 7, 6, 7. But no, we're doing 76. 6, 7 would be this, 67. Ethan would be 1, 2, 3, 4, 5, 6, 7. So this, what Ethan had mentioned, is now 12,345.67. That's 9. Oh yeah, thank you. I'm happy you're awake. Maybe I should end the live now because I'm already very tired. All right. So what are we doing? Thank you everybody for joining. I hope you can.
Now open your mind to me, please. Open your mind.
All right. Because the reason why is this is a different way of adding and subtracting, multiplication and division. We can do adding, subtracting, multiplication, and division on the abacus. But the first thing we need to do is we need to understand how to read the abacus, if that makes sense. So here, JFlow has a number, 953. I'll do 953. That's what it looks like. We have 900, so remember, this is our hundreds. 9, 5, 6, 7, 8, 9. 50 is here, and then 3. 1, 2, 3. Multiplication. Multiplication. You want to do multiplication right now? All right. Oh, Um, Jeremiah, how are you doing? Are we ready for multiplication, or we continue on adding and subtracting? Let's do a little bit more adding because Jeremiah is still very new to this. So the first thing we're gonna do, already learned adding. Yeah, but there's still other people in the class that don't know how to add. So Jeremiah, just so you know, no matter how big and burly your hands are, when you move the beads, you want to use the edges of the beads. So when we move it, right, it will look like 1, 2, 3, 4. But you can't see it because you see the top level. But don't be aggressive when you do abacus because it doesn't help. The reason why is because your answer will be wrong if you're too aggressive. So what's going to happen is you're going to be gentle. Just be gentle with it, and you'll be happy. When you're happy to do abacus, then your answer is going to be fine, right? So what we're going to do is make sure, if I have this question here and I want to add the 4, don't flick too hard.
And flick. Oh, flick too hard, damn it!
Don't be like Zeus and flick too hard. You want to make sure that you flick gently. So when we're doing, if we had this all and I want to add the 4, I just need to add the 4 just like that. And then the other thing is it's very easy to move the beads. It's very easy. So if it's so easy to move the beads, use your left hand to stabilize the abacus so then you can move the beads. Because if you don't, then everything moves, right? Because it's very easy. It's very slippery, right? So this is all made out of plastic and the colors mean nothing. Why do I know? Because this one is also made out of plastic and these are all and these are all the same color. We can do 7 plus 8. But it would require some. You
need modification! Modify!
So let's see what we need to do. One of the things we need to understand is that there is a set formula, right? Now we're just kind of jumping through. So what's going to happen is when we look at it, notice that what we're going to do first is we're going to understand how to move the beads. When I go to the horizontal bar, we're adding. When we're subtracting from the horizontal bar, we are taking it away. Does that make sense? So when we add, we go to the horizontal bar. When we subtract, we go away from the horizontal bar. When we are adding 6, so this is 1, and we add the 6, we go to the horizontal bar. When we subtract, we go away from the horizontal bar. And notice that there's a number pattern. Make sense? Bryce, how do Okay. So the first thing we're going to do, let's put a pin on that, Aura. And then we will do 7 plus 8. But the first thing we do is we need to understand how to move the beads. Yeah? So, when we look, right, the idea is you want to make sure you understand to only look at the add-in, because it's all about how we add the numbers. When we look, we're going to look at the add-in. We're not going to look at the result. Does that make sense? So when we look, we have 5. 5 is on the abacus. And then my question is to add the 3. I don't need to know how to make an 8. What I need to do is understand how to make a 3. Can I make a 3? Is there enough beads? Can I do it?
Yes, we can!
Yes, we can add 3 beads. So my final answer is 8. When I look at 4, it's the same thing. If I have 5 and I want to add the 4, right, there's enough beads. My final answer is 9. So again, what we're doing is we are moving the beads. When we move the beads, we have 4. When we have the 4, we take away the 2, we are taking away, right? That makes sense? Take away the 2. Bryce, does it make sense on how to read the abacus? So when we're adding, right, we go to the horizontal bar. When we're subtracting, we go away from the horizontal bar. So here is 8. So if I have 8, 5, 6, 7, 8, and then take away the 3. When I take away the 3, I'm going to take away these 3 beads. 1, 2, 3, and I take that away. So my final answer is my final answer is 5. The top bead will always be 5, no matter what. If I did this, this is all 5. 5, 5, 5, 5, 5, 5. If you do 6, this is all 6. This is all 7. This is all 8. And then this is all 9. Right? So then you might be asking, well, how do I do 10? Well, if this is 9, 10 will look like that. Just like 1 and a 0. 1 and 0. If I do 20, 2 and 0. 30, 3, 0. 40, 4, 0. Make sense? So what we're doing is we're understanding how to read the abacus and moving the beads. So when we look, we have, we did the 4. Okay, now we're at the 5. When we add the 5, again, what are we doing? We're adding the 5 to the horizontal bar. So my question starts with 3. I'm not going to know what the I'm not going to know what the result is. What I need to do is understand that my add-in is 5. My add-in is 5. Do I have enough to add the 5?
Yes, we can.
So we add the 5. My final answer is 8. Thank you, Aura. So again, we have 4. When we have 4, my question is do I have enough to add the 5? Yes, I'm going to add the 5. My final answer is 9. So it's the same thing with the 6, right? If I have 2, this is 2. On the abacus, I put 2. My question here is to add the 6. Is there enough beads to add the 6? Yes, there is. I'm going to add the 6. Now again, remember, when I take away, we're moving it away from the horizontal bar. When we add it to the horizontal bar, right, now we're adding. We're moving it to the horizontal bar, we're adding. We move it away from the horizontal bar, we're subtracting. So, we have 7. If I have 2 and I want to add the 7, I'm going to be a big person and put it all together like that. That's 7. You could do 5, 6, 7, but we're big people, right? We're going to do 7, just like that. Okay, so my final answer is 9. Okay, we're done with that. So the next one is, what happens when there's not enough beads? Now, why are we doing this? The reason why we're doing this is because I want to show you the fundamentals. Once you am I still online? What's it? Use the tense when you don't have enough. Yes. Let me see if I can. Can you guys hear me? Mixer. Okay, good. I'm still, nope. Oh yeah, no, I'm still good. Okay, good. All right. So, no. Hold please. Hold please. Hold please. My camera just died. Hold please. LQ cam? Nope. LQ cam? Yep. Nope. LQ cam. Nope. Hold please. Sorry, technical difficulties. Nope, that's not what I want. Cancel. Oh. Uh-oh. Okay. Webcam. That's not it. Cancel. Nope, that's not what I want. Oh my god. Ugh. Okay, so let's cancel this. I don't know. Can I find, where's my camera? Camera. Oh my gosh. Hold please. Where is my camera? Oh, I know. It's because of this. Okay, let's try that again. Let's try that again. All right. Sorry. Ah, there we go. Is that it? No, that's not it. Cancel. This one? This one? Okay, hold on. I think I got it. Oh my god. Okay, good. Is that right? Apply. Now I'm upside down. No, that's wrong. Cancel. Oh no, I did that wrong. Okay, wait. I gotta do this one. This one. And then you can see my dirty, messy room. And now I'm gonna do this one, which will be my camera. Okay, almost. Almost. No, I'm wrong. Oh my god. This is horrible. Okay, so here. This goes to here. There we go. Hello. And I go back to here. I apologize. All right. What are we doing? I don't know if I've... Okay. Okay. I try to stop when I don't have... Is this a better way? Sorry. Why is it better to learn with an abacus? Why is it better to learn with an abacus? Because you could see it, right? So here's an example, right? We know what 4 plus 4 is, right? We know what 4 plus 4 is. It's an easy question, but how do you know what 4 plus 4 is? We teach the kids to memorize, right? That's fine. You want to teach the kids to memorize, that's fine too, right? Or what do? We tell them to do number line. So 4, 5, 6, 7, 8. You could do that too, right? 1, 2, 3. But then what happens when numbers get bigger, right? So if the numbers get bigger, then what do you... Let me show you. So the first thing we're going to do is we're going to understand we have some restrictions. The other thing is, if you notice, if I give you a blank sheet, the sky's the limit. Abacus gives you a little bit of restriction. And so it forces us to utilize the tools that we have. So the first thing we're going to do is we're going to understand how to make a 4. When we make a 4, what does that mean? What we do in Abacus world is we understand that we want to look at our add-in. In mainstream math, in elementary school, we always focus on the result. Why is that better? You tell me. Why is it better to know what the result is? It's not. Because we change it when we go into algebra and calculus, right? We never know what the answer is. So why do we teach the kids how to make an 8? I don't know if user is still here, but does that make sense? Like, what's the point? What's the point of knowing what the answer is? We all know that everybody's to be happy, right? What it is, it's all about the journey. Okay, I think I'm back. So what we're doing is we're going to focus on the add-in, right? So there's many ways to do things, of course. Mainstream math, we focus on the result. But in Abacus world, we focus on the add-in. So here, we have 4. Notice we have a constraint, right? We need to add a 4. But we can't add a 4. What do? We know this one concept. Why? Here's another question. Why are we teaching kids how to make a 5? There's a question. Can I cheat on the abacus? No, you can't, actually. Unless you look at somebody else's. But if they're fast at moving the beads, then it's very difficult to cheat. So user 397, here's a question. Why are we teaching hey, Jihan, why are we teaching the kids how to make a 5? That's a question. You're so funny. Okay, that's a question, right? Just like, is it better? Well, yeah, because I'm telling you why we need it. In Abacus, I'll tell you why we need it. We need it so we can add 4, right? Yes. Thank you, user 397. Yes, because we have a 5 on the abacus, we can actually utilize this concept. What we can do now is we can power up our concept. Does that make sense? So is it better? I think it is, because now there's a reason why we're doing it, right? We go through...
You need modification! Modify!
So here we have 4 plus 1 is equal to 5. Ah, see? There you go. Because I want to isolate the 4, right? This 4 is the same thing with this 4. Because we're looking at the add-in. Yes, yes. So...
Welcome to the real world.
all we need to do is substitute the 4 with the 5 minus the 1. We add the 5 and we take away the 1. And my final answer is 8. Is this more difficult? It's different, right? Oh, I keep milking. It's different. Is it better? I think it is, but I'm not judging, right? I mean, I think it's better because that's why I'm teaching it. Everybody thinks differently, right? But see, that's the thing. And we can do it again. We can be versatile. So when we look, we have 3. When we add the 3 on my abacus, oh, wait, what do I do? Instead of memorizing doubles, right? Doubles plus 1, doubles minus 2, whatever, right? Instead of learning your doubles, instead of memorizing your doubles, why do I have a 4? I'm going to add the 4. To add the 4, I'm going to plus the 5 minus the 1. And then my final answer is 7. And...
this is the way.
This is the way.
This is the way.
is this how the kids that can add fast in their hand? Yes. So when you see the kids in the videos, they do this, it's because they're using the abacus and they can see it in their brain. Do I promote it? I don't. My kids don't do it in their heads. But if they need to, they can put it in the abacus and they can do it. Hey, Genzilla. That's great. Thank you. Thank you. Thank you so much. So does that make sense? User 397? You know what I mean? Like, is it better? I think it's better because you could see it. You could see how everything moves. So let's do again. Let's do 2, right? If I add the 2... and I want to add the 4, we know we're going to, 2, and I want to add the 4, again, all we have to do is plus the 5 minus the 1. And my final answer is 6. So let's take it one step further. Right? Let's do this question. And this will be easy. You'll see. So we have our number. We have 1, 3, 5, 7, 8. How would you solve that? Oh, no. You're welcome. But no, let me take it one step further. This is just because I'm very passionate. Let's take it one step further, right? Let's do, like, what do they do in school? They say, well, make friendly numbers. My numbers can be friendly, that's fine. But I want my numbers to work, right? So here's my question. Do I have enough beads to add the 2? Yes, I do. So I don't need to do anything. I just need to add the 2. Here's another one. I need to add the 4. When I add the 4, is there enough? No. So what did I do? I can scale it. Now it's scalable. This concept is now scalable. I want to add the 5 minus the 1. And then I'm going to add the 3. 3. So I'm going to add the 3. There's my 3. And then I add the 1 and I add the 1. So then... what is my final answer? My final answer is 37,889. See? But that's what I'm saying. It's easy to see how overwhelming it can be, right? This is like, why are we doing it? Well, let's take it one step further and let me give you a bigger number. That's why abacus is better.
This is the way.
This is the way.
This is the way.
Can you do another one like that? I can do many like this. I have a whole lesson. And we can go all the way to multiplication and division on the abacus. And I was just doing some research. Oh yeah, so this one. So here's another one, right? Now we're going to get a little bit complicated because now we're going to go into a little bit more. So we have 34 plus 14. Okay, so 34. We have 30, we have 4, not a problem. And then we have 14. Well, in mainstream math, some of the teachers are teaching it this way, where they do separate number bonds, right? They break up 30, break up 4, break up 10, break up 4, right? And then they add the 2's together, and then they add the, right? And so quickly. Okay, this is what they're doing. Okay, that's fine. Let's do it our way. Let's do it the abacus way, right? We want to add the 1. When we add the 1, now what do? We're going to add the 4. Remember how to add the 4? We know how to add the 4. Plus the 5 minus the 1. That's it. So my final answer is 48. Right? We can do more, but I mean, everything revolves around adding a 5 and adding a 10. What Abacus does is it breaks it down to more manageable chunks. It breaks it down to just ideas and understanding. So the question is, yes, Abacus is a better way. Is there algorithms? Yes, there's algorithms we need to understand, but there's only a few that you need to really know. And then there's this framework that you have to go through. Okay? So the reason why we do it is so we can it's like a process. They call it procedural fluency. So here's the framework. Here is the idea. When we have 7, the question will always be, and I've started this, right? Here is my 7. When I add the 4, is there enough beats to add the 4? Yes or no? No. So I'm going to go here. Can I add the 5? Yes or no? No, because I'm using the 5. The next step is to make a 10. In mainstream math, we call this carrying what? Carrying over, right? Carrying, regrouping, grouping, trading, all that, all those names. In Abacus world, we're only saying plus the 10. We plus the 10 minus the 10. That's it. Plus the 10 minus the 10. I want to add the 4. To add the 4, we know how to make a 4. To make the 4, it's plus the 10 minus the 6. I'm going to plus the 10, and I'm going to take away the 6. So my final answer is 11. You could do number bonds. You could do the number line. Or you could do it through the abacus. Right? You could do blocks. You could do a bunch of blocks. But see, it goes back to this is now scalable. Because when we have bigger numbers, now I got to make up a number. I got to make up a number. Okay. Let's do 9, 5... 5, 3, 2, 4, and then we 3, 2. This one is 1 and 6. All right, I just made up some numbers. Okay, so let's see how this goes. 1, 2, 3, 4, 5. Oh, that's the wrong one. I did too many numbers. All right. That's all right. So what's going to happen? The colors mean nothing. They're just pretty to look at, right? So what I wanted to show you was these numbers, they're all the same. When we look at it, the top bead will always be 5. The bottom bead always has a value of 1. When we have it, you'll notice I have my indicator, right? My 1's indicator. I choose one of these to be my homes. Because I choose one of them to be my home, I'm just going to choose this one right in the middle. Just because I like to be balanced. I like to be right in the middle. So when I add my numbers, I'm going to have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 9, 5, 5, 2, 4. All right? So what we could do is we can find a friendly number. I don't know why you would want to, but I don't know. But in Abacus world, what we do is we want to add the 6. When we add the 6, we want to plus the 10 minus the 4. So we're going to plus the 10 minus the 4. Is there enough beats to add the 1? Yes, I'm going to add the 1. Is there enough beats to add the 3? Yes, there's enough beats to add the 3. Is there enough beats to add the 2? Yes, there is enough beats to add the 2. And then I want to add the 3 here. Oh, sorry. I want to add 3. Hello, Neon. I want to add the 3. When I add the 3, it's plus the 5 minus the 2. So all I have to do is plus the 5 minus the 2. And my final answer is, I don't even know what my final answer is. My final answer is 156, 680, what? 84, 7. Ooh, I did that wrong. 1, 2, there. What? 1, 2, I wrote it wrong. 1, 2, oh, I did this one. So, My number is 8. I doubled it. 8, 4, 7. There we go. There we go. Right, I wrote it wrong. So, I don't know if that made sense. Okay, so the first thing we're going to do is we understand that now, because we know how to make a 10 and we know how to make a 5, it is now scalable. Yep. All right. So that's adding. Okay, are we done? Are we going to do another one? We can do another one. We can do a simpler one, right? A simpler one just means more foundational. You want to do multiplication? Oh, wait. Somebody wanted 7 plus 8. So the first thing to understand with 7 plus 8 is now we start going into what we call two-digit equation. So we know when we have the 7, right? 5, 6, 7. We're going to have 7. The question is 7 plus 8. When we add the 8, what are we doing? We know when we add the 8, right, we need to plus the 10 minus the 2. This is the pair. 10 and 8 is equal to 2. So when we look at it, we're going to modify it, and we're going to do plus the 10 minus the 2. What does that mean? Plus the 10 just means 1, 0. That's 10. 1, 0. We're going to plus the 10 and then take away the 2 and then take away the 2. So my final answer is 15. Jeremiah, I think, asked about that question. So the next question was this one. 80, right? 80, and then plus 39. Plus 30 plus 9. So the question is can I add a 3? Can I add the 3 to this column right here? No, I can't, so I got to go down here. Can I add a 5? No, I can't, because I'm already using it. So then my final one is to plus the 3, I need to plus the 10. So my final answer is 119. All right, did that make sense? I know I was pausing a little bit. How are we doing? Okay, just in general. Okay, I don't know if I'm back. Hello, welcome back. I think I lost people. All right, so what are we doing? We're back in business, it seems. Yeah, all right, cool. How are we doing? Do we need to do a review of this? I don't know if Aura's still around, but I did answer that question. Anybody have any other than multiplication? Hey, yes, thank you. Thank you. Thank you, user 397. Oh, wrong one. All right. How are we doing? Do we want to do a review? Anybody new? My name is Lynette. I am an Abacus teacher. I've been teaching Abacus for, I don't know, 20 years now. I have these books that I've created. They are available here. This is what the framework of learning the Abacus. We only do arithmetic. We only do adding, subtracting, multiplication, and division. But if you're looking for some of my books, I have it in the TikTok shop or I have it here. My name is Lynette. Welcome. Welcome to my life. Welcome to the world of Abacus, because that's all I do is talk about Abacus and numbers. And I have all these workbooks. So if anybody's interested, I do have workbooks. I do have a one that is a bead recognition. Bead recognition, right? 2 digits, which means that this is a maze, and this maze, you just kind of answer what the maze is, the question. Oh, good, I'm back. All right, so what is this? This is the Abacus formula, and it's kind of cool because I wrote out all of the cumulative properties and how we can use them, and then this is how to make a 5. This is how to make a 10, and I have it like organized in that way. And so there's a making of the 5. When you know how to add, right, we're going to add the 4, you know how to subtract the 4. When you do the 3, you know how to add the 3, we're going to be able to subtract the 3. And they come with sample questions and what we're doing at the bottom. And so after the 5, we do the 10. And then after the 10, it's the same thing. You know how to add the 9, we're going to subtract the 9. If you add the 10, add the 8, we're going to subtract the 8. So here, we're subtracting the 8. And then we have 7, 6, 5, 4, 3, 2, 1. And then we have our final cum de resistance. I don't know what it is. So this is the abacus formula. So again, the abacus formula is there enough beads? If there is, then just add it. If there's not enough, then we'll figure out how can we add it. So if there's not enough beads, you keep going down the pipeline, the workflow, and you're set and done. And that's it. So that is what this is. This is what we call the abacus formula. It's like, yeah. So here is the question that I had. Okay, good. I don't know if that worked. My camera. Hold, please. Camera. Where are you? No? There. There we go. Okay, good. Gosh. What a wonderful night. What happened to 4 plus 4? Okay, good. I'm back. Wow, this is not so good. This is what happens when technology kind of craps out. All right, 4 plus 4. So when we look, oh, you know what? We'll do that. We'll do this one. 4 plus 4. It's right here. So if you look at 4, let's do this first and I'll review what the big number is, right? So we have the 4. When we add the 4, right, we have 4. On our abacus, we add the 4. Notice I don't have enough beads to add the 4. When we do this, we are doing 4 plus 1 is equal to 5. Notice this is the concept. I would love teaching math. So when you notice 4 plus 1 is equal to 5, we're learning this in mainstream math. But in abacus, what we're going to do is we're going to...
You need modifications! Modify!
To modify it, we're going to isolate the variable. When we isolate the variable, we're going to isolate the 4. And then we're going to substitute 5 minus 1. When we do that, that's what we're doing here. We want to add the 4, but we can't because there's not enough beads. There's not enough beads to add the 4. So what do? We have to substitute plus the 5 minus the 1. I'm going to plus the 5. I'm going to take away the 1. So my final answer is 8. So we don't memorize 4 plus 4. What we do memorize is the concept of how to make a 4. So what we're doing is we're utilizing this 5. It's not complicated. It's how else would you teach 4 plus 4? We could do number lines. That's fine too. We could do number lines. So how do you do number lines? Well, number lines is like this. 1, 2, 3, 4. 4, 5, 6, 7, 8. You could do that. 1, 2, 3, 4. You could do that, but it's not scalable now, is it? Because when we start talking about big numbers like this, you want to do a number line? Go right ahead. We would have we could have pencils. That's a lot of pencils. 1, 2, 3, 4, 5. That's 5. That's 95,524. You're going to use 95,000 pencils? That doesn't make sense. And then you're going to add 61,323? That still doesn't make sense. But I'm showing you the fundamentals. I'm showing you. So who is it? Oh, user. So when we do it, right, we have 9. We have 9, 4, 2, 5, 5, 9. Then we want to add the 6. Remember how we added the 6? We added the 6, right? When we added the 6, what did we do? We know that when we're adding the 6, we want to modify it, right? We have this concept how to make a 10. When we make a 10, right, we have 6 plus 4 is equal to 10. Okay, so we're doing is we're going to isolate the variable. When we isolate the variable, we're going to do a 6. So 6 is equal to plus the 10 minus the 4. When we do minus, a calculator is the next step. Owl, thank you for your input. Thank you, user. Let's see. Owl, you can move on. If you don't
Now open your mind to me, please. Open your mind.
that's fine too. So, wait, Owl, let's get 95,000 pencils, and then you can start figuring out how to add 61,000 pencils. That's fine too. All right, 2559. Okay, what are we doing? So here we're going to add the 6. When we add the 6, we're going to plus the 10 minus the 4. Okay, we're back. So we're going to plus the 10 minus the 4. I don't know where we left off. I'm at the 6 right now. So then my final question is 1. Right? I'm going to add the 1. Is there enough beads to add the 1? Yes, I'm going to add the 1. Is there enough beads to add the 3? Yes, I'm going to add the 3. Is there enough beads to add the 2? Yes, there's enough beads to add the 2. And now we're here. Is there enough beads to add the 3? No. There's not enough beads to add the 3. How do I know? Because now what we're going to do is we're going to utilize this 5. Remember how to utilize the 5, which Owl mentioned. It is basic math. It is very basic. Right? So it's the concept of plus the 3 is equal to 3 plus 2 is equal to 5. So what we're able 3 equals to 5 minus 2. So when we look, we are
You need modification.
modify. So when we just like I completely forgot. We're going to just like algebra. So what we're doing is we're showing you the beginning steps of algebra. Cool. So what we're going to do is we're going to plus the 5 and then minus the 2. And so that's my final answer. So my final answer is 156,847. All right? I don't know, user, did you get all of that? Because I know I glitched a few times. Okay. How are we doing, user 397? Do we need to do it again? Whew. I think I need to do it again. Oh, you got it. Okay, good. Because I know I glitched a few times, and I tried to pause when I have glitched. Oh, there we go. Yes. Today's not a good day for a live. Yeah, it's been very glitchy for me too. And I'm hardwired in. Okay, you're getting it. Okay, good. So notice that the abacus puts a restriction, and it's kind of cool because, really the sky is the limit. But when you notice, because the sky is the limit, and then we start going into showing the children too many ways to do so many different things. Just as I showed you how it just depends on how you want to explain it. I choose to explain it with the abacus. You could use pencils, and you can use erasers, you can use apples. Only when you have 30 kids in a classroom. But you could do that. That's not a problem. And you might lose. Okay. Thank you guys for staying with me on this. Okay. We can continue on with doing some more addition, right? And subtraction. Or we can go into multiplication. I don't know how everybody is, but it seems like everybody is okay with the adding and subtracting. Are we? Do we want to? You know what? We can do a two-step equation. Let's do a two-step equation. What does that mean? Well, a two-step equation is the next level, right? So in one of my students, their mother was like, well, isn't 8 plus 5 the same as 5 plus 8? And it's like, no. The reason why it's not the same is because it's all about this add-in. Okay? It's always about the add-in. And you'll see that there's a restriction. So when we have 8, I want to add the 5. When we add the 5, we know what to do. When we add the 5, what are we doing? Live is. All right. I don't know where we're at. I'll keep my my camera. I'll keep my keyboard there. So we're back to here. 8. If I have 8, I want to do 8. 8 plus the 5. Plus the 5 is what? Plus the 5 is equal to plus the 10 minus the 5. So I'm going to plus the 10 minus the 5. And so my answer is 13. Right? TikTok has been glitchy badly for the past. Yeah. I think so. Yeah, you're right. I remember there was a whole news article about it too. So here is 13. We understand that, right? So the next one is if I did it the other way. Now, again, if I did it the other way, this is where we come into problems. Not problems. This is where we get a little bit more involved. So what we do is we understand we have to Tetris our worksheet, Tetris our formulas. What does that mean? We have 5 on the abacus, right? If we have 5 on the abacus, we're going to add the 8. When we add the 8, we know 8 plus the 10 minus the 2. We know how to add the 8. When we add the 8, it's plus the 10, 1, 0, 1, 0, 1, 0, plus the 2, minus the 2. I cannot minus the 2. I got to talk fast just in case I glitch again. So minus the 2, there's not enough beads to minus the 2. What do? We know how to make a 5. Minus the 2 is equal to minus the 5 plus the 3. That's what we can do. So if you notice, it's very similar, right? What we're doing is we're compounding our knowledge now. We're not changing anything drastically. We're compounding our knowledge. So our knowledge is 3 plus 2 is equal to 5. Now we're going to take away. When we take away, it's minus the 2 minus the 3 equals minus the 5. So we get our formula that we isolate. Minus the 2 is equal to minus the 5 plus the 3. So I'm going to minus the 5. See how plus the 3. I'm going to minus the 5. I'm going to add the 3. So my final answer is 13. I hope I got that. Was that okay? Are we all right? So what happened? Well, what happened was my here is where I had to substitute this information into here. How did you get the 10 again? It keeps glitching. Oh, okay. So plus the 10. When we make an 8. When we make an 8, it's plus the 10 minus the 2. What did we just do? We're going to isolate the variable, which is an algebraic. We're going to substitute this information, this 2, into the 8. So when we look, 10. Notice when I was counting, I did 9 and 10 looks like this. Remember that there's a 1 and a 0. 1 and 0. So when we want to add the 10, all we have to do is add 1, 0. 1, 0. And then we have to take away the 2. When we take away the 2, we can't. We got to do minus the 5 plus the 3. So I minus the 5 plus the 3. And my final answer is 13. Cool? I hope I got that. I hope you got that. Yeah. I get a few people, I get a few owls like that. And they're not open to a different way of thinking. I mean, there's many ways to do math. I kind of did, thanks. Okay, good. Yeah, it's hard when it glitches too, because it kind of ruins the stream. So we can do another one. You know what? We can do this one, right? So we have 80. Yeah, the glitching is really bad. So we have 80, 8 and a 0. We have 8 and a 0. 8, 0. So what we're doing is we're going to add 39. When we add 30, we add 9. We don't have enough beads to add the 3. So this is where the formula, this is where the What? 920? You got 928? That's crazy. That's awesome, Audrey. Okay. What we're doing here, add the 3. When we add the 3, we go, can we do the beads? No, we don't have enough to add the beads. So we got to come down here. Can we add the 5? Oh, me? Ah, ha, 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 ha. Thank you so much. 1K. Woo, woo. Can we add the 5? User 397. Can we add it? No, we can't add the 5. So what do we need to do? This is where we go. Plus the 10. We have to add the 10. So to plus the, what do we do? 3. Plus the 10 is equal to plus the 10 minus the 7. When we want to add the 3, plus the 10 minus the 7. Plus the 10 minus the 7. I'm going to take away the 7. And then plus 9. And I add the 9. That's all I'm doing. So my final answer is 119. Audrey. Thank you so much, Audrey. Thank you for the heartbeat. It's really bad tonight. The TikTok is really glitching. Really. Yeah. Okay, good. Hopefully. Oh my God. Oh, and then I had a person that did not open their mind to Abacus. It was great. It was fantastic. And they're like, just use pencils. And I'm like, yeah, for like this number, go ahead. You can use pencils. You just get 95,000 pencils. And then you add 61,000. Oh my gosh. Anyways, I'm going to stop. I got to stop. So, okay, so that's what we're doing. So when we add the 10, this is what we do. So every time we do a number, I had to leave and come back. They were really out there. Yeah, you know what? It could be because it's a Friday. Yeah. Yeah. It's okay. It's okay. I appreciate user 397. I was able to convince user 397 that Abacus is the way.
This is the way.
This is the way. This is the way.
Oh, and that was the other thing. There was another person that was, she does algebra or something, and she was like very inspired because I was teaching math, and she was like, I want to do it too. I was like, yes, do it, so then we can have a little groupie of math people. No, thank you. You're teaching me something new and valuable. Yes, no, I appreciate. No, I appreciate that you have opened your mind.
Now open your mind to me, please. Open your mind.
The 10 confuses me because I always want to. Yes, no, that's good. You want to start with the 5. The thing is always start with the 5. If you can't do it, then you go to the 10. So that's the good thing. It's always good to start with the 5. Thank you. So Edgar, does that make sense? You always start with the 5 when it comes to the 3. The 4, 3, 2, 1, you always want to start with the 5. And then if you cannot do it, then you go to the 10. So it's good that you're being confused, but it's good that you're starting at the 5. Yes, you always want to start with the 5. If you cannot, then you go to the next one. Yeah. Hey, Kryptonics. Just join and I'm already like, no, you're not. Silly. You're so silly. So when we do it, Edgar, I don't know if you're still around, but that's what it is. You always want to go to the 5 first. Okay. How are we doing? We can do more big math. Or we could just go regular math. So we could do like that. We do 5. We do 11. 3, 6. Right? 6 plus 5, easy. Easy, easy. Easy, easy. What is 5? So we do 5 is equal to 5 plus 5 is equal to 10. 5 plus 5 is equal to 10. So when we do this, we're going to isolate the variable. We isolate the 5. When we isolate the 5, it's plus the 10 minus the 5. Plus the 10. Remember when we plus the 10, It's a 1 and a 0. All we got to do is 1 and a 0. 1, 0, 1, 0. So I'm going to add the 1, and I have a 0. And then I feel isolated. And then I'm going to minus the 5. So my final answer is 11. So that's what we do with the plus 10s. So then after the plus 10, it's the Tetrising way. And which is really cool because this would be a good question. If I can find it. Oh. So here's another good question. So now you understand how to do the two-step. There's more. But wait, there's more. When we do, I think it was like 54 plus 9, right? What are we going to do? When we do 54, we're going to put this on our abacus. Kryptonics, you're so funny. So we have 54, and then we want to add the 9. When we add the 9, what do? We know we're going to, please put it in the chat, this equation. This equation, put it in the chat. Plus the 9 is equal to plus the 10 minus the 1. So what I'm going to do is I'm going to plus the 10 minus the 1. So I'm going to plus the 10 minus the 1. What was I supposed to do here? Plus the, oh, we're supposed to do minus. So my final answer is 63. But it's supposed to be the other way. All right. Oh, hey, Copper, welcome back. Kryptonics. Thank you so much for the kitten. You're awesome, kitten. Oh, my. I've been dealing with, yeah. Today was a very tiring day. All right, how are we doing? Okay, this one was supposed to be the other way. So let's do it the other way. If we do 54 minus 9, that's what we're supposed to do. So I have 54, and I take away the 9. To take away the 9, oh good. Minus the 9 is equal to what? Minus the 10 plus the 1. So what are we going to do? We're going to minus the 9, right? Minus the 9 here. We need to minus the 10 plus the 1. Minus the 10 plus the 1. Can I take away the 10? No, I cannot take away the 10. So this, what do? Minus the 1 is equal to minus the 4 plus the 5. That goes to here. Minus the 5 plus the 4. There we go. Minus the 5 plus the 4. And then this one, I need to plus the 1. Can I add the 1? No. I need to plus the 1 is equal to plus the 5 minus the 4. Oh, thank you, Audrey. Don't forget to tap. Don't forget to tap. So, I'm actually really tired today. It's crazy. Plus the 5 and then take away the 4. So we're going to take away the 4. My final answer is 45. Oh, sorry. Okay. How are you guys doing? Make sense? So what was this? This was a more than 2-step. This is 3 steps. Why? Because we started with the 9, right? And then we had to substitute this one and then substitute this one. So right now that looks like it's a 3-step equation. Are those the old scented markers? They are. I don't know if they're that old, but yeah, they're the scented markers. This one was Mr. Sketch. They still smell, and they still sell them. So I don't think they're old. So that's what this is. All right. How are we doing? Those new people who are new. Welcome. My name is Lynette. I'm an abacus teacher. All I do is talk about adding, subtracting, multiplication, and division with an abacus. How are we doing? Do we want to know? We have to count. 1, 2, 3, 4. They're still available. 4. Anytime the beads are touching the horizontal bar, this is the horizontal bar. Because the beads are touching the horizontal bar, this is counted as 4. And then we have 5. 5 is the value. The top bead will always be the value of 5. We have 6, 7, 8, 9, and then we have 10. 10 is 1 and a 0. 1, 0. What you gonna do? When we do 10, then we can do 11, 12, 13, 14, and then 15, 16, 17, 18, 19, and then 20. So this is 20, 2 and a 0. This is 30, 3, 0, and then 40, 4, 0. All right, how are we doing? What do we want to do? Whew. What's going on? What's going on? Huh. I wonder. Okay. So we did a little review. That's the little bit of review. How are we doing? We can continue on. Oh, I wonder, copper. Did the adding and subtracting make sense to you? I'm really curious. Did the adding and subtracting make sense? So what we can do, I don't know if they showed you how to do skip counting. So let's do some skip counting on the 5. Oh, hey, look at that. Thank you for the follow. So, when we look, we have 5. I stepped away for a bit. Now I'm back. No, the glitching hasn't stopped. So copper, 5, 5, 5, 5. Did they show you how to do this? This is a little bit of multiplication. Copper. So when we look, we add the 5. That's what this one is, right? Not much today for me. I slept most of my day, my friend. What do we have? Oh, that's not good. Are you okay, Copper? So here, we're just going to do a little review on our times table. So if I want to add the 5, right, I'm going to add another 5. Do you remember how to add a 5? This one right here. So if I add the 5, it's what? Plus the 5 is equal to plus the 10 minus the 5. That's what we're going to do. We're going to plus the 10 and then minus the 5. I'm okay. I'm not feeling my best today because of my... Oh. You know, yeah. I think for me it's the weather. I think I should have went outside for a little bit longer, but I didn't. I got lazy. So then we're going to add another 5. We're going to add another 5. This is a 5 we're going to add. Right? So what's my times table right now that I'm looking at? Do you know, Copper? So if I have my 5, right? I have my 5. How many times am I right now? Not quite yet, user. We're just talking about how to add, how to do a little bit of times table. And I'm just showing her how to do it on the abacus. So this one is 3 because I'm doing 1, 2, 3. So yeah, the answer for this one is 2. So we have 5 times 2 because we have 1, we have 2. Then we do 5 times 3. Then we have 15. All we got to do is add the 5. Yeah, no worries. So, Copper, when we do, we just need to add the 5. Can we add the 5? Does that make sense? We're going to add the 5. She was just mentioning that Copper didn't know how to do multiplication. So I was just trying to review a little bit of multiplication. So if I have 4 5s, right? This is the other 5. It's 5 times 4. How do I know? 1, 2, 3, 4. So when I go on my abacus, can I add a 5? No. So I know I need to plus the 5 is equal to plus the 10 minus 5. So I'm going to plus the 10, I'm going to minus the 5. So my final answer is 20. That's it. All right. Thank you guys for the hearts. Thank you guys for the hearts. It's interesting. It's just interesting how. So in Abacus, we have to memorize our multiplication fact. Just so you know. So that's one of the things, and this is a segue to going into multiplication on the Abacus. The reason why is because on the Abacus we would be doing commutative property. Accumulative addition is what we would do on the Abacus. So here, thank you so much for the hearts. So here, when we do 2, let's do 3, right? It's the same thing. If I do 3 plus 3 plus 3 plus 3, it's the same thing as doing that on the Abacus, right? So now, when we do it, we have 3, right? To add another 3, there's not enough. I need to plus the 5 minus the 2. Plus the 5 minus the 2. So this is now 6. Right? So we're going to add another 3. Can I add another 3? Yes. I'm going to add another 3. That's this one. That's a 9. So now my next question is, can I add another 3? It's going to take me a while to figure out multiplication and understand multiplication. Well, here's a question, Copper. Do you understand how to add all of these? That's the question. If you know how to add, that's one step closer to multiplication, if that makes sense. So that's why we're doing this, right? And I'm showing you, if I want to add a 3 to this, I cannot add a 3. What do? I need to plus the 10 minus the 7. So again, these are formulas that we need to memorize. So we go to plus the 10 and then minus the 7. I'm going to take away the 7. My final answer is 12. So here I will write 12. Does that make sense, Copper? So that was just a little segue. We can review again next time. But that's just the idea. To understand, when you add, is what we're doing fast adding with multiplication. Okay? So I think we're ready for multiplication on the Abacus. Okay, so that's the little bit of a segue. When we look, what are we going to do? In Abacus world, we do not need to know anything higher than 9 times 9 because we have to memorize that. What's going to happen is we're going to start utilizing it. So here's a question is 23 times that by 6. So in Abacus world, what we're going to do is we're going to do distributive property. Distributive property. Okay? No matter what, that's what we're going to do. We're always going to do it. When we do multiplication, we'll always do it. So here's a question is, when we figure it out, we need to find our starting point. 1, 2, 3. How do I know what our starting point is? Because I'm counting all of my digits. I barely know my plus numbers, but I can do it. Okay, good. Did the formulas help? Because what I would do is I would just continue to do the formulas until it becomes until you memorize it. I start my children with this. They got tired of it. And so yeah, no worries. I understand. But that's the thing, like, that's where I would start the kids. That's where I start my kids. They hated it. So they started to be like, you know what? This is taking too long. And they would start to see the patterns. So then what I would do is I would focus in what numbers resonate with you. I started with the 5 because it's easy to show on the Abacus. I did 3 because I wanted to stretch it out a little bit. I've been in and out. I'm doing errands, but I'm listening again. Okay, that's okay. It's just the two of us. I don't know if Audrey's still around. But what we're going to do is we're going to do distributive property. So here's a question. Here, 6 times 2. What are the numbers on the abacus? This is 0. R and T for life. So that's 0. Hey, Audrey. Okay, you're still here. So we're going to review. This will be good. Yeah? This will be 1, 2, 3, 4. Anytime the beads are touching the horizontal bar, this is 4. They're being counted. 1, 2, 3, 4. When they're being counted, right, this is now 0. Does it matter which one you Rose use? Yes. Yes, because 1 is different than 10, which is different than 100. How do I know? I have a label right here. If you notice I have a label, there's a dot. That dot, I will choose.
Okay, Charizard, I choose you!
That's a good question. So I choose this one, right? Just like a Pokemon. But if you notice, I have another one over here, right? So it doesn't matter which one you choose.
I choose you!
But I choose this one. The reason why is because if I choose this one, my ones, my tens, and then I have no more room for hundreds, thousands, or 10,000. That's why I choose this one. So I go here, I do my ones, my tens, my hundreds, my thousands, my 10,000. Does that make sense? So when I look at it, I have 4, and then the top beat is always a value of 5, no matter what. This is 5. And then we have 6, 7, 8, 9. After 9, we have 10. 10, if you notice, looks like 1 and a 0. So if I show you 1, 0, and then I have 11, 12, 13, 14. Yes, any which one you want. It doesn't matter. As long as you know that it's like, it just depends on how big your answer or how many digits you're using. Every column is a digit. That makes sense? So if you look, this is a 13 column abacus, which just means that's 13 digits because size matters. So this one is only 7 columns. So you can only do small numbers, right? Small questions, small numbers. And then the kids go graduate into a bigger set. So here, there's 1 here, 1, 1, 1, 1, right? These are all the labels. But notice they are grouping by they're groupings. So when they become groupings, they go ones, thousands, millions, billions, and then trillions. Actually, user 397, your brain is the calculator. The abacus just tracks your numbers. It will become apparent when we do this. So when we're doing the multiplication, right? When we do multiplication, what we're going to do is we're going to read the numbers, 1, 2, 3. So we know we're going to be on the 100s. When we know we're going to be at the 100s, now what we're going to do is we're going to know, right? We're going to do 6 times 2 is equal to 12. I put my 1, I put my 2. That's it. But in mainstream math, we say 6 times 20 is equal to 120. Why? Because we're writing it out on paper. But on the abacus, it tracks it for us. Does that make sense? So that's why I just stay within my times table. My times table is 6 times 2, or 2 times 6 is equal to 12. Right? I'm just using the commutative property on this. But it doesn't matter how we do it. Right? Because it's multiplication. So when we look on my abacus, I have 120, which is great. Because then what are we going to do? Then we do 3 times 6 is equal to 18. See, I did that one in my brain. All I got to do is just add the 1 and then add the 8. My final answer is 138. That's it. Bam!
This is the way.
This is the way. This is the way.
Because we could see it, we'll just add it. Easy? How's that for you? Ha ha ha! That was too fast. Okay, let me go back. I apologize for going too fast. I know I go too fast because I get so excited. I get so excited. Let's do it again. 1, 2, 3. 1, 2, 3. I'm going to be at the hundreds, right? What's going to happen is I go 6 times 2 is equal to 12. I do 1, I do 2. Audrey!
Welcome to the real world.
So what are we going to do now? Now we do 3 times 8. 3 times 8 is 18, right? That's all we're going to do is we're going to do 18. All we have to do is add 1, 8. We have to add the 1, we add the 8. Add the 1. Can we do it?
Yes, we can.
So we add the 8. Add the 1. And then we go over here. Can we add the 8?
Yes, we can.
Yes, we're going to add the 8. So my final answer is 138. That's it. So when we do mainstream math, all it is 3 times 6 is equal to 18. And then we have to, what do? We have to add this and add this together. That's it. But it's easy to see on the abacus that you can do it, right? There's no formulas involved. Thank you, Stephen. 3 times 8 is 24. Okay, R and T and user 397 and copper. How are we doing? Audrey, what's going on? We can do some more multiplication. Doing okay. Yeah. But what we do in Abacus World is we always do distributive property. We don't do anything else. We just do distributive property for multiplication. I'm following you perfectly. Oh, fantastic. Right? Easy. Easy. Simple to use, easy to understand. It just gets a little hairy when we start to do adding and subtracting with formulas. This is easy. I'm trying to understand. Okay, great. How about the books? The books. We did talk about the books. I got to do my multiplication books, but I haven't done the books yet. Oh, I did do the books, and then I started glitching. So I did do the books, and I started pinning them too. So thank you, Audrey, for the reminder. I did do the books. I started off with the books too. Okay, so we can do more multiplication. Oh, okay. So copper. Now I'm quite curious, right? When we do 6 times 2, 6 times 2. We have 6 on the abacus. We want to add another 6. To add another 6, can we do it? No. Oh, this would be a 2-step. Oh, sorry. I'm getting tired. All right. I think we'll do one more, and then I'm gonna sign off. Not enough spaces. Not enough. You're right. So let me continue my thought. I almost got sidetracked. So because we don't have enough, we're gonna do 6. Now, if you add another 6, right? 6 plus 6. We're not going to memorize this. What we're going to do is we're going to understand our add-in. This add-in is what our problem is. So if I don't have enough, my question goes here. Because I don't have enough, I'm going to go down here. I cannot, use a 5 because I'm looking for 6. So I come down to here to plus the 10. Plus the 10, right? To add the 6 is plus the 10 minus the 4. Plus the 10 minus the 4. Plus the 10 minus the 4. Maybe TikTok doesn't like how to carry on the 10s. Plus the 10 minus the 4. So when I add 6, it will equal to plus the 10 minus 4. So I plus the 10. Okay. Now I have to minus the 4. Can I take away the 4? No, I cannot take away the 4. So what do I need to do? I'm going to put it in parentheses, and I'm going to go back to my formula. I'm going to go back to my framework. Can I add the 4? Yes or no? I cannot add the 4. I cannot minus the 4. There's not enough beads to minus the 4. Yes. Can I use the 5? Can I take away the 5? Yes, I can take away the 5. So what I'm going to do is I'm going to minus the 5 plus the 1. My final answer is 12. Thank you, user 397. So my final answer is 12. Because what did I do? I said minus the 4 is equal to minus the 5 plus the 1. And then this gets substituted into here. Yay! I'm starting to get it. Yay! You've been getting it. Yeah, you have been getting it. Copper, how about you? You all right? Does that make sense? This is a two-step. Why is it a two-step? It's a two-step because we started off with 1, and then we had to substitute this one. I call it a two-step. Abacus World calls it a mixed formula. And I'm like, that's BS. Hey, Jeff. All right. Why do I think it's BS? Because we have more than just this to be a mix. It can be anywhere. So as long as you know the foundation, it's does the two-step dance. Does the two-step dance. Yeah. Yeah. Because I showed you here, right? This one. This is more than 2 steps. But if I just called it mix, that's so non-specific. I was like, what? That doesn't make any sense. All right. So, Jeff, let's do this. Let's do this. All right. 1, 3, 4. Times that by, I was using my hands to, yes, you can. You can. Because you have 5, you have 10. You take away 6. You take away 6, and you have 4 left. Yes, you could do that too. You don't have to use the abacus. That's a good idea. I do that with my hands for making a 5. When we go to the cats in the tree, you know how I used to use the money? I use my hands too. Okay. So what are we doing? We are doing this. We have to count it again. That's a good way, Copper, that's a really good way of using what you have, right? And that's what Abacus does. Abacus uses what you have. All right, so what are we going to do? We're going to count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm over here. Why? Because I started my 1s over here. The first thing we're going to do, again, don't forget this is distributive property. Because this is distributive property, what we're going to do is we're going to do 9 times 1. 9 times 1 is equal to 9. 9's a single digit. I have to go back one column, I add the 9. I'm adding the 9 right here. Sometimes people understand it to be 0, 9. And when we make it a two-step. I was taught to use my hands to count when I was little. Oh, that's good. Oh my gosh. Yx squared. I don't know, Jeff. I don't know that. What are we going to do now? We're going to do 9 times 3. 9 times 3 is 27. I add 2, I add 7. Thank you, Audrey. It's not a 2x. It's not an x squared. I don't know how to figure that out. Oh, I forgot how to write it out. How you're supposed to, anyway. I don't know. That's above my pain grain. Okay, wait. 2 7, 27. I want to add 2. I want to add 7. I know I don't have enough beads to add the 2. To add the 2, I need to plus the 10 minus 8. Plus the 10 minus the 8. 5, 6, 7, 8. And then I need to add the 7. Add the 7. 9 times 4. 9 times 4 is 36. Add 3, add 6. Add 3, add 6. Plus 3 is what? Plus the 10 minus 7. Plus the 10 minus 7. Plus the 6, because we need to add the 6. There we go. So we are done with our 9s. The next thing we're going to do is now we got to do the 7. Oh, thank you, user. Yes, exactly. That's what it is. Plus the 10 minus the 7. Good. So now we have to just regroup, right? Recount it. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I'm over here now. 7 times 1. See, we go from left to right. 7 times 1 is equal to 7. 7 times 1 is equal to 7. 7's a single digit. I go back one column, I add my 7. 7 times 3 is equal to 21. I add my 2, I add my 1. 7 times 4. 7 times 4 is 28. I add my 2. Is there enough? Yes. I add 2. I add 8. So my final answer is 12,998. How is that for you? Yeah. Thank you, Jeff. Good teacher. Thank you. Hopefully that was slow enough. Right? Did that make sense? Cool. And hey, Eve. All right. All right. You guys are hilarious. I think I'm starting to get... Can we do it again? Yes, we can do it again. Okay, let's do a review. Let's see. Yeah. Okay. So, thank you, Edgar. Okay, copper. What we're going to do is we're going to count our digits. 1, 2, 3, 4, 5. Okay? We have 5. So we know we're going to put our answer here. 1, 2, 3, 4, 5. I'm going to put my finger here. Now what do? We will go from 9 times 1. So we always start from left to right. 9 times 1. 9 times 1 is 9. 9 is a single digit. I go back one column and I add the 9. Thank you, user. It takes away the addition adding at the end of the long because you're doing it. Yes. Yes, because you do the addition along the way. Why do we go back? Because when we're talking about time, let me correlate, right? So what time is it right now? For me, it's 10:08 right now for me. Notice this is a single digit, right? What time is it for you? Tell me what time it is for you. I am in California. Aha! Are you okay with that? Not too many people enjoy that I'm in California. Right. See? 1008. See, Audrey is 109. 109 a.m. Hey, Pancho! Welcome. So it's 1109. All the best people. It's the Common Core. So when you look, right? I got family in Cali. Oh, good. So, Eve, when you look, we made our we made our single digit. These are single digits, if you notice. But we made it double digit, so it's easy for us to understand. Because we never say 10, 9, right? We have a 0 in there. Does that make sense? When we do the date, right? If we do a 2-month date, it's 05, 16, comma 25. Make sense? Or if we did like May the 4th, 05, comma 04, and then 25. Does that make sense? So what we did is we made it a 2-digit, even though it's only 1 digit. That is why we go back. Stars Day. Yeah, Star Wars Day. Exactly. But notice we made it 2-digit. Does that make sense, Eve? So when we do here, that's why I do this. If it's 9, we're going to make it into a double digit. We go back 1 column. So the 0 helps us go back 1 column. That's why. So then our next question is 9 times 3. 9 times 3 is 27. 27. I want to add 20. I want to add 2. Cannot add the 2 here. I have 9. So how do I add the 2? So my question is 9 plus 2. I don't know if that's confusing. So 9 plus 2 is what I want to do. 9 plus 2 is 2. I don't have enough beads to add the 2. So what do? I have to plus the 10 minus the 8. So I plus the 10 and I minus the 8. Don't forget to add the 7. So I got to add the 7 over here. I add my 7. Now what am I going to do? I'm going to do 9 times 4. When I do 9 times 4, 9 times 4 is 36. I add 30, I add 6. 36. What is my question right now? It's 1170. And I need to add 36. Does that help, Copper? 1170. 1170. I need to add 36. I need to add 36. Is there enough to add 3? No, there's not enough to add the 3. Thank you. So what do you do? Yes, Copper, what do you do? We need to plus the 10 minus the 7. Thank you, user. I'm going to plus the 10. Look at this. Plus the 10 is my carrying over. And I need to take away the 7. So I'm going to plus the 10, take away the 7. Right? That's my 2, 0, and then don't forget to add the 6. Hold on, Nick. I need to finish this question. I need to add the 6. Oh, 6. So right now I have 12,060. My ancestor calculator. Okay, so we're done, Copper. We're done with the 9, right? We're done with the 9. Now we go back and we do 4. We're counting. 1, 2, 3, 4. 1, 2, 3, 4. So now I'm here. I need to start over. So 1, 2, 0, 6, 0. 7 times 1. 7 times 1 is 7. 7's a single digit. All I got to do is go back 1 column and I add the 7. So I go back 1 column. 0, 7. I add my 7. Thank you, Thank you, Pancho. Yes. So then, what do? 7 times 3. 7 times 3 is 21. Do I have enough to add 21? 21. Okay, it's starting to make sense. Do I have enough to add 21? Yes. Copper, how are you doing? Yeah?
Yes, we can.
20, 2, and a 1. And then what do? 7 times 4. 7 times 4 is 28. Is there enough to add 28? Add a 2, add an 8. Add a 20, add an 8. Is there enough beads to add a 20 and an 8? Yes. Add a 20, add an 8. So then my final answer is 12,998. Yes. Good? Good. 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 Just like Lilu in Fifth Element. Good. Chicken good. Chicken good. Okay. So for those of you that just came in, thank you, Bon Bon, for the compliment. Yay, did it. Yay! Copper, see? It works. It's just I'm talking multipass. Yeah, right? Lilu Dallas multipass. Okay. So Copper, that's what I'm saying. I believe you can do it. It's just you didn't have the tools. And if you are okay with this is how we do it in Abacus. That's how we do it. We always do it this way in Abacus. This part doesn't change. It just, no matter how big your numbers get, you'll do the same thing. The only thing is that I would be like, you would have to make sure you track your numbers. It would be even more clear if you had a graph paper big enough to match the size of the abacus. Oh yeah, that we could do that. The slower you explain it, it's better for me. Yeah, I know I talk a little bit fast too. Because I'm so excited. So that's why it's good if you ask to do it again, I will do it again. Thank you. I appreciate that. Okay, so for those of you that just joined in, we're going to do a little review. So I'm not sure if anybody's here, but other than the people that have been with me, numbers can match up with the abacus numbers. Yes. Yeah. Yes. But I wonder if it gets a little bit more confusing. I know that we look at numbers so it's easier to see. Yeah, I could think about it. I would have to marinate on that a little bit. Graphing paper. Yeah. Okay, so what we're going to do is we're going to read the abacus. This is 0. Because this is 0, none of the beads are touching the horizontal bar. And you were questioning me.
Welcome to the real world.
I got jokes. Okay, so we're going to count 1, 2, 3, 4. Anytime the beads are touching the horizontal bar, this is what's being counted. So we have 4, right? Then the top bead will always be 5. We have 5, 6, 7, 8, 9. So then you might be wondering, well, what happened to 10? 10 is a 1 and a 0. Just as how we write 10 is exactly the way we read it. 10, 1, 0. Now we can count by tens. 10, 20, right? 2, 0. 30, 3, 0. 40, 4, 0. And then 50, 5, 0. 60, 6, 0. Does that make sense? So when we go through this question, this number right here, 12,060. To do 12,060, we do 12,000, right? 0, 6, 0. That's what that number looks like. Yeah. And yeah, I do believe that the more we work on it, the more easier it gets, obviously. Because it's all about just practice. And that's the thing. As we keep going through, it's all about practicing. And we just keep practice. And that's the other thing is we practice the same thing like a piano. Right? It's just like practicing the piano. The keys are all the same. It's just how does it all fit in? So just as the abacus, we have our fundamentals, we have our building blocks, but then we have to figure out how does it all fit in. Cool? So, isn't that 1 million? No. Why? Because if you notice, I have this ones indicator. This is my label. This is my ones indicator. But that's a good question, Mark. This is my ones indicator. If you notice, I have another one over here. Because I have another one over here, I need to choose one like a Pokemon.
Okay, Charizard, I choose you!
So when we look, I'm choosing this one because that's where Charizard sits. You could choose this one, but then you would run out of space because then I'd be my tens and my ones. Ones, tens, and then notice the hundreds are not here. There's no hundreds, thousands, and 10,000s. So then, because I choose this one,
Okay, Charizard, I choose you!
as my ones indicator, this is my label, this is where my ones would be. So essentially, this would be 60.72. That's what that would look like. We need graphing paper like that. All right. So, how are we doing? We're all right? So that's the beginning. That's the little review of, that's the review. Okay. If there's no other questions, I am going to sign off. It's been a while. With all the glitches. My goodness, so many glitches. All right. How are we doing? If anybody's okay, if everybody's all right, I'm going to sign off. Thank you. Talk tomorrow? Yeah, okay, let's talk tomorrow. See you later, Mark. Wait, I got one. Okay, Pancho. Okay. What is it? You're so silly. It was going to be a big one. This one, at least Jeff made it nice. Yours was like not nice. This one was nice. Jeff made a good one. Good night. Good night, Copper. I'll see you tomorrow. I'll see you guys tomorrow. All right. Have a good night, everybody. Thank you guys again for joining me. I'm going to sign off. Have a good night. Yeah, not a problem, Copper. We will continue on learning more multiplication. I agree. Have a good night. Appreciate you. Oh, yeah, I appreciate you too. Even though with the big questions. All right. Have a good night, everybody. Thank you, guys. You work my brain. Oh, good. We're going to continue on understanding multiplication because I believe you can do it. It just takes a little bit just to see the patterns. I believe you can do it. It just takes time. That's all. World Traveler from LA. Okay. I'm going to sign off. Good night, everybody. Thank you, guys.